All right, we are moving on to Unit 6, which is all about arrays. So arrays are just a new storage type that we're going to be using that's going to allow us to uh, store many pieces of information into one variable, essentially. And so they're different than the objects that we've created, but also kind of the same, which you'll see here in a bit. But for those of you that are coming from JavaScript, there are going to be some key differences. So one of the big differences in JavaScript, uh, the arrays that we could use could include many different types of data. And so I could have strings in there, and I could have numbers in there, and I could integers or floating points or booleans or whatever. Versus in Java, these arrays will be specifically storing one type of information. And so just like anything else in Java, we have to be a little bit more specific and actually give it the type that we're using. So we're just going to jump in and look at what arrays are. So if I want to make a new array, we're just going to start off with an array of integers. And so what it looks like is that I start off, it's an array of integers, so int, and then I'm going to use these two square brackets. So this tells me that what am I creating? I'm creating an array of integers. These brackets will come to mean array to us in many ways. And so I'm going to create a new name here. We'll just call it x to keep it simple. And then how we actually create a new array is we're going to use the keyword new. And so what you might be thinking at this point in time is like, well, the only time we've used new in the past has been whenever we've been defining objects. And so what I would tell you about arrays is that arrays they're kind of like objects, but they're not objects, but really they're objects. And you're gonna see why that is here in a second. What I mean by that is under the hood they are objects. They are they have a lot of the same characteristics obviously objects do in Java, but they're just like a special type where just the way that we create them it's just different. So there's gonna be a lot of similarities that you're gonna see, but under the hood they are objects. So I'm gonna say new, which means I'm actually carving out a new piece of memory over in the heap. And then I'm going to tell it what type of array that I want again. So this is a new set of integers. And then in my brackets, I'm going to put a number, which is the length of the array. This is another big difference between Java and JavaScript is that I have to say how many items are going to be in the list. What we're going to find out later is that technically in JavaScript, if we really want to give an analogy between Java and JavaScript here, the lists that we use in JavaScript aren't really arrays; they're array lists. But we'll talk about that later. So this is what we have, which is great. So let's just test out a couple things first. So system.out.println. Let's just see what happens whenever I print out my array. So what we should be able to do is stop and think like, okay, what should this print out? And if we go back to what I said, a few seconds ago, which was that, these arrays are kind of like objects, but not objects, but really they're objects. And so what I should expect to see is the same thing that happens whenever I print out, an object. So I'm going to go ahead and run this. So compile, and this is fun with arrays. And then, man, I already screwed something up. Public class fun with arrays is public should be declared in a file named fun with arrays. Oh shoot, fun with arrays.java. I mistyped something. Oh, there it is. Okay. Golly, that was gonna take me a long time to figure out. Just a typo, no big deal. Let's try it again. Java compile fun with arrays. Whew, okay, good. Fun with arrays. Perfect. And so what I'll get here is again this hashed memory address. So we're not going to worry about that much right now, but that's just, kind of referring to this memory location space because again, what's actually being stored on the stack is a reference to a location on the heap. So next, I'm curious to know what exactly is in my array. I haven't actually put anything in it. I've just kind of set aside these spots. So what happens if I actually try to access an item? And so how do I access an item? Well, if I want to get an item from the array, each of the elements in my array are indexed, starting at 0. So in this case, if I have 5 items in my array, I have indices of 0, 1, 2, 3, and 4. And so if I want to look at, let's say, the thing at index 2, the way that I get that is x at 2. And so I will go ahead and print this out, and we'll see what's there. And I guess I would stop here and think, like, so what do you expect for this to be printed out? Well, let's find out. So if I compile again and I run, and what I get is 0. And so that's interesting for a second. So why 0? You might have expected some type of like, well, this value hasn't been initialized. So there's something different. If I try to just declare a variable, like an integer variable on the stack, and then print it out, I without initializing it, I'd run into a problem. But this is a little bit different because it's being created on the heap. It's going to give this initial value of 0. 1, if it was an object, it would be a null pointer. But I'm just going to get my default values, kind of like we did when we had wrapper classes back in the day. And so doubles will be 0.0, booleans will be false, and so it's just these default values that they're going to have. So question is then, how do I actually start doing some things with this? Like if I want to actually put some values in here, I guess that's maybe one thing I should talk about really quick first, is there's another way of declaring a list or an array. And so if I create a new array, all the items in this first array have a value of 0, but if I actually want to define them as something first, what I can do is use my curly braces to actually assign some values to it. So if I want to put in here the numbers of 4 and 6 and 4 again, I could, and so I would have an array of 3 elements, and that would be just fine. It's another way of defining my array. So what's going to be our best friend when working with arrays, though, will be lists. Because right now I've just created 2 arrays of length 5 and 1 of length 3, but what if I want to have an array that's much longer than that and do something with it? And so the answer is, well, I can use loops to what's called traverse the list, or rather the array. And so what that means is traversing is using a loop to look at each item in the array and either just look at it or do something with it, depending on the situation. So what we're going to do is let us create a function, not a function, but let's just write a for loop here. I'm going to get rid of some of this stuff. I just want my initial array. So let's say I wanted to create a for loop that is going to store a random number in between 0 or 1 and 10 into my array for each item. And so what I will do is I will have some type of index or incrementing value that I'll start at 0. What I want to do is I want to look at each item in this array, starting at 0 and running up until the last index. And so how do I know what the last index is? In this case, I know that there's a length of 5, so the last index is 4. But in general, I might not know that. And so what I'm going to use is the length of my array, just kind of like what we did when we looked at strings. The difference is that whenever I looked at the length of a string, it was something to the effect of like x.length, and then that was a method for strings. The difference here is reminding ourselves that arrays are objects. What we're actually going to do is get the attribute. There's a public attribute that immutable public attribute that stores the length of the array. And so what I can actually do is I can access that by saying x.length. And so what this will do, this will run up until, so the last index will look up at 4, and then once I increment to 5, then I will be past the length at that point. So I++, if I want to look at every item in here, and let's just give every item a new random number. So I'm going to do that by saying, okay, x at index I, what it'll be equal to is, and so then I'm going to cast to an integer. What am I going to cast to an integer? Well, I'm going to take math.random and multiply it by 10. Now, if I just did this, I would get numbers 0 through 9, which in this case would be just fine, I guess. But what I said earlier is I wanted the numbers 1 through 10, and so I will add 1 to that. Perfect. Okay, so this is going to randomize numbers in all of my slots, and then let's write another for loop to print all this out. So for integer I equals 0, and then I is less than x.length, just like we did before, and then I++. I want to print out every item in my list. So the way I'm going to do that is system.out.print, oh boy, print line, and then what am I going to have? Value at index and then plus I plus, and then colon, space, and then x at I. Perfect. Yes, I think so. Okay, let's go ahead and do this. So what I think I've done now is I declared a new array of length 5. I've given random numbers to each of the values or to each of the elements, and now I'm going to print them out. Let's go ahead and see what errors I made. Oh wow, huh, how about that? Okay, perfect. So I randomly generated 5 numbers, 3, 9, 2, 8, and 10, and they all got stored into those indices. Perfect. All right. Let's look at one thing. I want to make one change here. Let's make an error. So if I set this, I want to say this is less than or equal to. So we should stop and think about what's going to happen here. So what's going to happen is I'm going to start at 0, increment to 1, and 2, and then 3, and then 4, and then 5. So the length of this array is 5, and so this is still good. This is still valid, and so I will try to access the thing at index 5, which doesn't exist. It only goes up to index 4. So the question is, what's going to happen? And so you might think that I'm going to get an error here whenever I go and compile this, but you would be wrong. And the reason for that is because Java doesn't know. Java looks at each of these lines and be like, okay, assigning a value, making a comparison, great. But like, I don't actually know what value you're going to access here. And so the issue is that what I'm going to get is not a compile time error, but I'm going to get a runtime exception thrown, which tells me that, hey, you're doing really well. We print all these things out until array index out of bounds exception. We tried to access 5, but the length is 5, and so that was no good. And so I'll get that exception thrown. This will be a very common exception that we'll get just because we're going to make off by 1 errors on a regular basis, which is, whatever. So I'll go ahead and change that back, and then we're all dandy again. Okay, so now I'm going to look at some functions. I'm going to make some functions here that kind of do the things just we did, that we just did. Yeah, that we just did. So we know about static functions now, right? Static methods. And so let's go ahead and write some static methods like for this class that we can use. So one of these methods is going to be the fill method. So what it's going to do is it is going to be a static method that returns nothing. But what I want to do is take in an array, integer array. We'll just call this my array. And what I want to do is just randomly fill it up with numbers in between 1 and 10. Okay. And so I'm going to take this function that I just made, or this for loop that I just made here, and slap it into my method and change a couple things here. So for integer I equals 0, x. Okay. So I don't want x anymore. I want my array and dot length. So that's all good. And then I want to assign this to be my array. Okay, so I just did this so that I can have a function now that I can use to randomly generate numbers whenever I want to. I'm also going to make a toString method, which is like a pseudo toString method, because this isn't like for a class, but whatever. It's going to return a string, toString, great. Oh, I need to throw in the array, integer array, my array. And then I'm just going to print out all the items in there. So I can use these functions now. They're going to be great. I'm going to use them here in a bit. It's going to be awesome. This is going to be my array. Great, fantastic. And then print this out. Oh, but this doesn't really make sense anymore. I don't want to print it out. I want to return a string. So I'm going to make a new string here. It's going to be called result. It's going to start off as nothing. Perfect. And then I'm going to set result plus equals, and then all this. But I'm also going to slap on a new line at the end. Okay. So I've just this is kind of called refactoring. where I've just written my code in a different way. It's going to do the same things I did before, but I've added this element of abstraction here where now I can use these functions for whatever. So there's some questions that I have to ask myself about what's going to happen next. So I still have my array of called X. I want to make it a little bit bigger. Let's make 100 items. Okay, big array. I want to fill it randomly with numbers. So the question you might be asking yourself here is like, well, so what do we know about methods? You know, whenever I take in a value like this and store all these things in my array, the parameter here, well, like that's not going to get passed back. It's not going to actually make a change to my array, right? Or is it? And so I have to really stop and think about how this is going to work. So let's go ahead and call it and just see what happens. So I want to fill and then X. Okay, so hopefully this should fill it with values. And then I want to system.out.println, let's see, to string of X. Okay. So the question is, what's going to get printed out here? Is this function, the fill function, actually going to make changes to X and give it random values, or am I just going to print out the zeros? So this is a totally non-trivial thing that we should put some thought into. So let's go ahead and run it, see what the result is, and see if we can make sense of it then. Oh darn, I was doing so well. Oh, I didn't change the name. Oh, I just can't type again. That's the second time I dropped an R. All right, fine. I think we're good now. Okay. Try it again. Oh, darn. Oh no. Okay. That one matches there. I should have looked and actually seen what it said, but I didn't because I'm a lazy bum. All these seem to match up. Where's the error at? Missing return. Oh, I didn't return result. That's my bad. Okay, return result. See, it always helps to actually read what the error was before just assuming. Aha! Oh, so I have all these numbers now that are randomly assigned. Okay, so what you're telling me is what happened here is I created this array, and then I passed it in as an argument into this function, and then when I made changes to this parameter in my function, it actually made changes to X outside. So why would that be? And the phrase that should come to mind here is pass by value versus pass by reference. So going back to my initial statement at the beginning of this video, which is that, arrays are, kind of objects but not objects, but really they're objects, is the fact that what's actually stored in X, well, it's a memory address. And so if this is a memory address, when I pass it in, it gets passed the reference to this array. And so the changes that I make to my array inside the function actually are made to the array outside of the function, which is super important here. And so we just have to be really careful whenever we pass in arrays to functions to make sure that it's doing what I want it to do as far as making changes to it. So that's worth noting that arrays, whenever I'm using them, they are passed by reference, not passed by value. So I'm going to do one more thing now. I have created a function to fill my array, which is great. I've created a function to print it. I want to make one more function that is a search function. It's just going to be a basic linear search. And so what I want to do is I want to create a function that public static is going to return an integer value for the index of an item in my array if it's the thing that I'm searching for. And if it's not in there, then I'm going to return -1. So what I mean by that is, so we'll call this search. I'm going to take in an array. So integer array, my array. And then, I almost did it again. And I'm going to take in an integer value. And I want to test to see if value is in my array. And if it is, I want to print out the index. And if it's not, then I want to print out -1. So how am I going to do that? So I'm going to create a for loop. I'm going to again traverse through my array and check each item individually to determine whether or not it is the item that I'm looking for. So for integer, and then I equals 0, I is less than my array dot length, and then I will increase I by 1 each time. I plus plus. I want to look at each item, test to see if it's my value. So if, and then the item at index I, so that would be my array at I, if it's equal to, and then the value that I'm searching for, what do I want to do? I want to return what the current index is. And so this will go through all the values in my array, and once I find the item at a certain index, I'll print it out. But the thing is, if I get all the way through this for loop and I never actually find the value that I'm looking for, I should just return -1. Perfect. Okay, let's go see if this works. I've already printed out my array, and then I'm just going to system.out.print print line. What item do we want to look for? We want to search X for the value of, I don't know, how about 7? That makes sense. Okay, let's go ahead and print this. All right, 14 is the first occurrence of 7. Is that the case? 14, index 14 is the first occurrence of 7, which is perfect. Okay, and so it cuts out right then and there the first time I found it. If I wanted to, I could keep going. I had to obviously rewrite my function. But this is a basic linear search. It's worth noting that this is not the fastest search that I can do. Well, actually, I take that back. It's the fastest search I can do with the list that we currently have. We'd have to do some sorting, which we'll talk about at a later point. But I feel like I have given you all the things for the kind of the basics of arrays. We've talked about how to declare and then also initialize or look at different values. We've talked about how to access them, how to traverse them, talked about the exceptions, all good stuff. So this is kind of our somewhat heavy introduction into arrays that we are going to use a whole bunch moving forward because there's a lot more we can do with. So yeah, there you go. That's arrays.